I'm Kate Meese. I'm an Associate Director at the Local Government Commission. I'll be providing a brief overview and going over logistics for our webinar, and then I'll turn it over to our speakers. This is the 14th of 15 webinars that we've hosted over the last 3 years through the Statewide Energy Efficiency Collaborative, which is a partnership between LGC, eQUEST, the Institute for Local Government, and the 4 investor-owned utilities. The partnership was established in the 2009 CPUC decision to help cities and counties reduce greenhouse gas emissions and save energy. A little bit about the webinar logistics before we get started. Due to the large number of participants, everyone will be muted for the duration of the webinar. If you have questions at any time during the webinar, please type them in the question box on the control panel window with the name of the speaker your question is intended for and click the send button. If you're having technical difficulties, write IT in the question box followed by the problem you are experiencing. We'll be trying to answer as many questions as possible through the chat function during the presentations. We will summarize the remaining questions for the speakers during the question and answer portion at the end of each presentation. The presentations from this webinar are available on our website. We will also be adding a recording of the webinar once it is available. When the webinar concludes, you'll be asked to complete a survey. Please take 5 minutes to provide us with input, which will help us to improve our future webinars. This webinar is focused on retrocommissioning at the local level. According to recent data, energy costs can account for as much as 10% of a local government's annual operating budget and as much as 30% of a building's operating costs. Most building owners are not aware of the sizable opportunities that are available to them in their existing facilities. Retrocommissioning investigates opportunities to improve and optimize a building's operation and maintenance. Local governments have the opportunity to work with building owners in their community to help meet energy and climate change goals and to reduce energy costs in their own facilities by ensuring that buildings are performing to the highest operational and maintenance standards possible. Research shows that retrocommissioning can result in approximately 15% energy savings for a relatively low cost and short project payback period. This webinar will provide an overview on retrocommissioning and highlight 2 local examples, including energy savings achieved, challenges faced, and lessons learned. We have a great list of speakers today, starting with Jeff Guild, who is Director of Energy Services at Innovity. He has more than 18 years of mechanical engineering experience with a focus on optimizing building systems. He holds an MBA from UC Berkeley and a BS in mechanical engineering from CSU Chico. So with that, I will turn it over to Jeff.
Hi, this is Jeff Guild. Glad to be here. Thank you, Kate. As you mentioned, I'll be doing an overview of retrocommissioning, talking about some of the technical aspects of it and some of the payback elements and some of the barriers and opportunities. And there's my slide. Let's just get to the agenda here for my portion of the talk. Next slide, please. Yeah. So back to the agenda, please. Thank you. So we'll be going through a definition of retrocommissioning, some of the benefits, some things about LEED buildings, and some commonly held misconceptions about LEED buildings, perhaps. RCX opportunity indicators for both technically minded people and non-technical. Some typical measures. Got a couple case studies we're going to go through. Some barriers and solutions, and some of the common RCX and partnership program services that building owners can take advantage of. So next slide, please. So the retrocommissioning, Kate did a good job giving an overview and defining it, but this is one that this is a definition that speaks to me. Just going to read it. A systematic method for investigating how and why an existing building systems are operated and maintained, and identifying ways to improve overall building performance. Kind of a nuance here. It's not just enough to know how it should be operated, but why. Knowing why a system is operated can often lead to a root cause, to finding the root cause for why something's been overridden, or something's been put into manual, or a schedule's been set up that may or may not apply, and all these things can lead to energy savings and comfort improvement. Next slide, please. So here's a little information, and this is from some studies. And throughout my presentation here, the slides will have references to the various studies I've pulled this information from. So you can see at the bottom, you can see the reference there. But just on a energy savings, the numbers can range. Looking at the chart on the left, for existing buildings, the typical range of savings is between 8 and 30% plus. And on new construction, retrocommissioning and commissioning can result in a similar range, although a little bit tighter. To the right, you can see the breakdown of the typical paybacks on a per measure or per technology item by item basis, and you can see that none of the paybacks are really going too far out in the future. They're all giving you a pretty good return on an investment. Some of them are really quick. Scheduling measures, not specifically measured here, can often be immediate. Essentially it takes less than a half hour to implement a new schedule, and that can be the savings from basically turning things off can be infinitely fast. So quite a range here, but all of it within a really good return on investment within 4 years here. So there's a lot of detail in these slides, and the slides will be posted from what I understand. So just for the sake of time, we're going to continue on here. Next slide, please. So here's just a different way of looking at it, rather than on a technical per technology type basis. This is more on a per building type basis. So again, fast payback times. The third column there, you're looking at your payback, and in the second column, the reduction in energy use. This is on a total building reduction. Next slide, please. So this slide is with regard to LEED buildings, and the point of this slide is to point out that there could be opportunities for retrocommissioning even if you have a new building. So there's kind of a lot of information in the graphic here. But for LEED buildings, an energy model is typically developed before the building is constructed. That serves as the basis for how much energy savings is, how it compares to some sort of baseline, Title 24 here in California. And if every model was perfect, you would see all the dots falling on that diagonal line from 0% up to the diagonal line going up from the 0% on the y-axis. And so that when I say perfect, that's meaning that the building performs as predicted by the energy model. So if every building performed as it was predicted, they would be falling on that line. And you can see there's pretty good grouping there. Some save more than expected, some save less than expected, and then as you can see, some buildings perform a lot significantly worse than expected. In fact, where you see the dots below the 0% line, those are facilities that actually not only do they not perform as expected, but they perform worse than a base code building. So if you've got a new building that's LEED certified, you might be one of the lucky ones that's above the line, above the diagonal line, but you could also be one of the you could be unlucky and not know it, unless you're paying attention to your energy bills, in which case you might notice. You can notice that there's quite a few gold and gold platinum buildings below the line, perhaps because some of those designs are a little bit more technically challenging to model, so maybe there's some variation there. But why does this happen? Overly optimistic energy models, changes in building use, the assumptions that went into the model are different than how the building's actually operated. The common factor is unresolved deficiencies from construction. So even though a building may be commissioned, that doesn't mean that there's not a deficiencies list at the end of construction because everyone's in a rush to get to occupy the building. Inadequate commissioning, just not done very well. And then when there's the commissioning's inadequate and there's unresolved deficiencies, oftentimes operators, when given the building to operate, just kind of throw things into manumatic, I like to call it, to deal with customer temperature problems and just kind of trying to put band-aids on a building that's not operating optimally to begin with. So that's enough on this slide. Let's go to the next slide, please. So here are some opportunity indicators. Some of these, you need to have a little bit of a technical background to recognize. Some of them don't. This is just kind of a list. Some of the ones that you don't need to have a necessarily technical background on are obviously the fourth bullet there, or equipment and lighting that's on when the space isn't occupied. Just driving down the street, you can see buildings that don't have their lighting schedules correct in the middle of the evening when there's no one occupying it necessarily. Going in and out of a building, you might notice that the doors are kind of perpetually sucking in or blowing out. That's a sign. That's a red flag. For those, the rest of these are a little bit more technical. You might need to know what you're looking at to identify them, but these are things that any maintenance person or facility operator should be able to identify. You don't necessarily have to be an expert in retrocommissioning to recognize these symptoms. And then the bottom one, which is my favorite indicator, is high energy costs, and that's relative. High energy costs, and there's kind of two things. Is you need to have a benchmark for your energy costs, so you know for your type of building and schedule how you're doing, and it's good to do baselining for that against something like Energy Star, not baselining, benchmarking against Energy Star. Another thing to look at if you have access to interval data, which is pretty common here in California through a lot of the utilities that have interval data. If you see high costs through the evening, through the hours that buildings aren't occupied, that's an indicator that you have things on when they don't need to be. Next slide, please. So here's some typical measures, and these are, depending on how technical you are, you might appreciate this slide or not. Reducing the supply fan operating schedule, adjusting the outside, the air side economizers, dead bands. These are some set point control sequencing strategies for duct supply air temperature set point, duct static. Let's see. Getting VFDs operating or adding them. A lot of times they're an override. They're just operating at a constant speed. Just enabling them or re-enabling the sequence that they were intended to modulate. To support HVAC, water side measures, lighting measures. A lot of things around scheduling here. Locking out the boiler when it's too warm outside. You shouldn't need heating if it gets above a certain temperature. All these things allow the variable nature of these systems to kind of throttle back, operate at their minimum, and not only does it reduce energy where it's at like the fan where it's spinning down, or the pump that's spinning down to maintain set points. It also can affect the efficiency of things like the chilled water plant and where the package rooftop unit that's trying to maintain it's trying to maintain 55-degree temperature supplier instead of 60. It doesn't work as efficiently. So it's certain aspects of these are reducing the load on the equipment, and some of them are improving the efficiency of of how the equipment operates. So that's enough on the technical aspects of the RCX measures. Next slide, please. Here's a case study for a lab, combination lab and office system that we just recently worked on. You can see it's just last month. This is an example. Up looking at the top half of the screen, you got the before on the left and the after on the right. So they didn't really have setbacks for the, they had lab spaces that need air all the time, but they had office areas that didn't need air all the time. So basically what was implemented was on an occupancy schedule for the VAV boxes that serve the offices. And what happened was, by implementing the schedule and closing off the VAV boxes that didn't need to be on all the time, you can see that the fan speeds reduced drastically between the occupied and the unoccupied times in the post period. Before, they were operating at a constant speed. Not all of them were at 100%. One was at 98 or 97, one was at 90, and then you can see in the post case, you can see them turning on and off to maintain static pressure in the ductwork, which resulted in, obviously, a lot of energy reduction. And then you can see that along the bottom graph here. This is the baseline reflecting the before case, the blue line, considerable energy use, pretty high demand profile relative to the post installation, which is considerably lower. So that and it's happening at all hours of the day. Actually, it's not just happening in the after hours. And the bottom graph is an average daily load profile for September, between September last year and September this year. Next slide, please. This is another example of a pre and a post. This one is using a whole building, looking at the whole building meter, doing modeling using a whole building approach, which some of the retrocommissioning programs are advocating, and it's a useful way to evaluate the savings on a facility, especially if there's a lot of measures that are kind of happening concurrently, and it's hard to disaggregate where the savings are coming from if you've got a building that's got a lot of things to fix. Trying to quantify the savings associated with each individual measure can get tedious, and it doesn't provide a lot of value. So there's a whole building approach using the whole building meter to kind of capture all the savings, and it doesn't just have to be retrocommissioning measures. It can be retrocommissioning and major retrofit measures as well. This the facility that this is from has had a combination of retrofits and retrocommissioning measures. You can see that the red line is the model, statistical model based on the actual meter data, and then in the post case, the red line's the model in both cases, and then you can see that in the post case how much difference there is between the actual metered and what the model predicted in the post case, and that reflects the savings when you annualize it. And so that's just a novel way to calculate savings for a retrocommissioning project. Next slide, please. All right, barriers and solutions. Oftentimes, customers, they don't know where to start. They don't know if they need RCX. They don't know who can help them do retrocommissioning, and they don't know how to fund it. One of the things that's really hard for a customer to swallow is, how do I know to hire someone to do retrocommissioning on my building when the retrocommissioning, the whole investigation, I don't know how much it's going to save. I don't know how much is, I don't know what the potential is, and it's hard to kind of stomach the idea of having to investigate to find that out, and pay for that investigation. You know, there's a lot of commissioning providers out there. You don't know if you've got a good one or not, and you don't know if you need it. So those are kind of the typical barriers and anxieties that our customers exhibit. And some of the solutions. So as far as understanding your facility relative to how well it could be doing, is you can do benchmarking, and Energy Star is a great resource for this. It's really quick and easy to do using a portfolio manager. If you've got a building that qualifies or is covered by Energy Star, and most buildings are, and that gives you kind of a score how you can compare to other buildings and gives you an idea of what the potential is for your facility. As far as having a good trust component in the retrocommissioning provider, referrals are always good, and then there's a lot of utility partnership programs out there that have qualified retrocommissioning companies that you can that they'll connect you with. The utility and partnership programs are also can be a source of funding. Besides being a pre-screening for quality retrocommissioning, they can also be a source of funding. A lot of programs will offer the investigation services up front at no cost, and also provide incentives for the actual energy savings that's achieved through retrocommissioning. And then on the payback, also on the funding issues, they're typically fast payback. So even though there does take some money to do some investigation and implementing of retrocommissioning measures, you know, they're typically on the average 2 years, you know, or less. Some measures can take longer, you know, up to that 4 years that the study had. But you know, you can find a lot of good stuff that'll pay back in 2 years or less. Next slide, please. And I mentioned the utility and partnership programs. These are some of the typical services that they'll provide, you can get a consultation to understand your facility a little bit better, and oftentimes do an assessment. Now, it should be noted that, you know, if you're going to do a full retrocommissioning on a building, doing like a full point-to-point, bunch of really detailed retrocommissioning, that's probably not what you're going to get as far as free services from a program. You're going to get more of a energy focus and more of an overview than you would be if you just paid outright for a retrocommissioning scope of work. But it is a good way to start the process and get an idea of if there's some retrocommissioning opportunities. You'll get support through the implementation. You also get a quantification of how much energy you've actually saved and greenhouse gas, and you also get the greenhouse gas impacts. And then it's always nice to get a cash incentive based on how much energy savings you're actually able to achieve. And so just a note on those pictures to the left, that's a damper. For those of you who don't know what a damper looks like, that could be I think that's an economizer damper that was actually one of our projects, and they'd been disabled or propped open by the 2x4 to keep fresh air coming in. And you can see that the nice new properly operating dampers down below. That's just, we've got our own wall of shame we keep here in the office, and that's one of the favorites. Next slide, please. That's it. Hopefully I didn't run too far over on time. Kate, I think I don't know if you want to do questions now or if you want to hold till the end.
We don't have any questions that have come in yet, so we'll go ahead and move on to the next speaker. If anyone has any questions for Jeff, go ahead and enter them into the question box on the control panel, and we will get to those at the end. So up next, I'm going to introduce Ron Moore and Narendra Armanani. Hopefully I got that right, with the County of Los Angeles. Ron Moore is a section manager with LA County's Energy Management System section. Ron oversees a staff of 16 individuals who are responsible for the county's HVAC, building automation system, metering, lighting, and other automation systems. And I'll introduce Narendra as well, who is a project manager with 30 years of experience in HVAC, retrocommissioning, CSP, cogen, renewables, and energy engineering. So I will turn it over to both of you at this point.
Hi, good afternoon. This is Ron.
And for short form, call me Amar. That would be easy on everyone.
Amar is the godfather of retrocommissioning in the County of LA. Can we get our next slide, please? The county's done retrocommissioning for around 8 years now. We've done retrocommissioning in over 50 facilities. They have a tendency to be our larger facilities. These are examples of the types of facilities we've done. We've done approximately 12 million square feet, spent around $13 million doing it. Retrocommissioning's averaged us about $1.10 per square foot. We have focused on the larger facilities. It's where most of our utility budget is spent. My personal opinion is that small facilities, for the most part, when I hear that people are doing retrocommissioning, I kind of just wince in pain, especially that I hear them that they're doing RCX on package units. I just think that if you're going to do package units in small facilities, you're just better to focus on your maintenance practices, do good repair jobs, and if you're looking at facilities with smaller size equipment, it's probably just good to look at the age of the equipment and replace it when it's old. So things go a lot better. Next slide, please. Our retrocommissioning, we started this out, and Amar's really the one who pushed our process. We do it in around a 10-step program. These are the steps. I'm only going to mention a few of them. That first part is the benchmarking. We take and we benchmark our facilities against the other facilities in our inventory, and it's to find our opportunities, either based on kWh per square foot, dollars per square foot, or whatever. One of the things that really I believe that drives some of the quality into our program and really gives us a kind of like the gold star approach is the fact that I hear a lot of people on RCX, and it seems to me that they're just doing really focused maintenance and repair jobs in their facilities. It's going out there, like the previous individual said, and doing engineering calculations using eQUEST or DOE or whatever's available out there, trying to determine from an engineering viewpoint what your facility should be using energy-wise, what your system should be using energy-wise, seeing how you compare to these calculations after you implement your measures and your adjustments in your facility, and seeing how you're doing it. I call it that's tuning your building. Sometimes you got to make adjustments in the calculation, sometimes in the facility, but it's the tune-up. You go out there and you just replace a bunch of stuff and repair it. It's not a guarantee that everything is working optimally. So next slide, please. These are the specific goals that we focus on when we do RCX. These are the areas. A lot of it has to do with the environment provided to the occupants and things like that. Not everything that you're going to do or not everything that you're going to implement is necessarily going to save you energy. There's certain activities that if you do implement them for the betterment of the environment, your energy usage should go up, especially on the air side, I believe. Next slide. We're moving fast because I just want to make sure that we're on time here. These are the specific tasks that we do, and it's pretty much the order that we do them in. It relates to that target type of slide. We start with that benchmarking. They go in there, they do the diagnostic testing and the pre-functional testing of individual components. If we identify things that need small repairs or adjustments, we do it at that time. And they start doing their models, and they work their way through it. We start implementing things, finishing up with the training of the people and having documentation. We just talked to some individuals today about some things that happened in their building a couple years ago, and what we did, what we put in for equipment, how it operates. They have a complete different idea after a couple years, so it's time to go kind of sit down and do some training again. Next slide, please. These are some of the specific RCX measures. This is the meat and potatoes of where we're getting our improvement in our environment. It's also the meat and potatoes of where we're saving the energy. It's the meat and potatoes of where we're getting our paybacks. Somewhere in here, I don't know if it specifically says it, but that whole simultaneously heating and cooling of the things. If I had to put a stamp on my number one thing I would look for right off the bat, that was it. Resets on your temperatures, on your heating and cooling, another big one. So that's kind of what we do, though, for the measures. We very much use the same approach as the previous gentleman mentioned with paybacks and stuff like that. Next slide. This is the heart of what we were supposed to talk about, where we had our problems, where we had barriers, how we got around things. We are a government agency. Selling this to upper management, selling this up to the budget people and all that, been very, very tight. We started in 2003. Since then, the budgets in the state of California they've become even tighter. Getting money to do this, it just wasn't going to happen. That's just the truth of it. You know, the money's going into maintenance, the money's going into public programs. This idea is a very kind of mental activity you've got to get your head around. It was tough to get funding. Almost all of our funding has come from outside the County of Los Angeles. It's either come through the utility partnerships or through some type of state funding and things like that. Once we get into the projects and measures are identified, some of those big cost measures, if we have to do big replacements at the boiler or the chiller level, or big capital replacements in the projects, it's probably just not going to happen. It's very, very tough to get that funding. Those are things that they have to plan out the funding sources for. That's a tough one to get. The way we went about it, though, is once we had the agreements with the utilities to get it, we went out on an RFP to evaluate and hire our providers. We provided all the work. We provided all the oversight. We did the project management. We did the coordination at the facility level. We're the ones that hired the RCX contractors and oversaw them. We're the ones that the documents came to, and we did the evaluations. That was on us. With the partnership, then we kind of just reported our results. We are very lucky in the fact that being large, we've got a dedicated energy management group. We've got some in-house experts. Amar really pushed this retrocommissioning, and I'm going to be truthful. I come out of a facilities background, out of a maintenance background. When they were talking about doing this, I wasn't buying into it. I thought if you wanted to operate the buildings and optimize them, just go talk to the staff that took care of them. Amar got going on this. He had a very specific idea of what he wanted to do. There was a gentleman in our local utility at the time that was on the same wavelength as Amar. They drove it. After the first year or two of the program and the results that they were getting, specifically in energy savings, I became a convert. So I went from somebody who wasn't into this to somebody who got big on it. They took buildings that were bad from the first day of operation, had been nothing but a headache for 10 or 15 years, and they turned the operation around in those facilities from the RCX, things that had never been corrected from the day the facilities were turned over. So as the previous gentleman kind of alluded to, one of the other barriers or conflicts that we have in our programs is because we're partnered with the utilities, sometimes the utilities are very, very focused on that energy savings. So there can be measures that don't necessarily have big energy savings paybacks or big energy effects, but they're going to help the environment of the building. And we push very, very much for those because it's the entire building we want to improve, not just components within the building. We want that holistic approach to what we do. And we have to very, very strongly make the fact that all the services that we're providing in kind for project management and oversight, repair work, the funding to do the repair in the small jobs, that listen, we're not coming out of here with a piecemeal building. If we're going to do this, we're going to improve the entire operation. And that whole kind of mindset based on the whole days of retrofitting things and looking at measures and payback, that when you do RCX, there needs to be an adjustment in the type of thinking. We want to improve the overall facilities operation. I'm done. It's now Amar.
Well, he's putting me on a red carpet now. Next slide, please. So first of all, I want to thank Ron for his kind words, but it is all the teamwork. He has actually carried through all this RCX buildings which are now complete, and he actually oversees the persistence of savings from this point onwards. He's with us on board right from the day one we start hiring the contractors, and we basically, buildings have lots of controls and lots of other things into it where require facilities input, and with his input we actually go forward to see what is going to work and what is not. RCS contractor is also our great team partner. Without their help, we just can't go any further. The other teams are with our maintenance organization, which are actually making it happen for you. If they are not on board with it, it wouldn't happen. We depend on them completely to provide us the information about what the existing condition is, to actually, once we are done with it, to actually take care of those buildings. And we have found them to be very, very cooperative. So this whole organization is required for RCS program to be working. Here are some hard numbers. We thought that it would be approximately on average, since our program has started, cost about over $1 per square foot to retrocommission a building, which actually excludes all the project management cost to it, because county has actually provided in-kind project management, maintenance kind of services to this particular project. This is the number, basically what the partnership secured funding from CPUC, LADWP, or the county CEOs. And our average projected savings are over the course of the time is about 44 cents. That gives us approximately 2 years of payback. Next slide, please. Statistics, we already talked about it. We have already done 12 million square foot, and our cumulative cost have been so far $13 million. And as we are moving along, so far we have saved $26 million. The rest of the other numbers are just the calculations. Next slide, please. And here is what the gist of it. Ron was emphasizing on it. Is we call it gold-plated, but call it gold-plated. I don't know what else to say about it. But not knowing where we are going with it and where we will actually reach, to me, that separates RCX from a maintenance point of view. So what we did was basically we dived into big-time investigation. As Jeff was talking before, we don't do point-to-point, but we actually do point-to-point in RCX. That has been the crux of this whole thing. Our buildings have been on average 30, 40, 50 years old buildings. I mean, not knowing what the status this building is in, just going there and doing a couple things here and there is not going to work. It's like not having one tire and moving along at the speed of 100 miles an hour is not going to work. So we want to actually know what's happening. When we went point to point, we figured it out, fix every link, fix every control, fix every circuit. Wherever it is wrong, just fix it. We took upon ourselves to do a maintenance kind of a work, but identified with M&O people what needs to be fixed. If those were costing more money, we used it as an EEM. So if you will see, we have used a free program provided by Department of Energy called eQUEST. Anybody can download it and work on it, and we run the models on it. And this is a calibrated model. And what we did was we actually measured all the values of all the energy consuming equipment, and then we input those values into the eQUEST model and had a calibrated output of it to match with the bills. And as you may see it here, we applied different energy efficiency measures to it to actually see which measures provide us the biggest bang for the buck. You will see very clearly in here that the space heating was the greatest energy waster of all time. We took actually control of that one. And the next one was working with the space cooling, and third one was ventilation fans. So this is the output from eQUEST model. Next one, please. And this is what actually represents this simultaneous heating and cooling. Once everything is fixed, you will come to know this is the biggest problem in a building. Fix your excessive heating problem in the building, and you will start having the control over your energy in the building. Because it takes a lot more energy to dump that heating which goes into the building, and everybody's kind of uncomfortable in the building about it. Next slide, please. It was mentioned earlier before, we saw that the savings were in the range of 15% to 30%. But by gosh, we have actually seen up to 50% of the savings. It is represented. And sometimes, very recently, repaired and retrofitted building also had that kind of a problem. So keep it in mind. You might be just going in and maybe finding the treasures by having the retrocommissioning done in the building. Main thing is you got to investigate and resolve the operational efficiencies. And then very, very systematically think about what energy efficiency measures you are going to put in. The only equipment change out sort of a thing we allowed into this program was VFDs, basically. I mean, we thought if VFDs are not there where the VFDs used to be, basically we're not going to cut it. So it always turned out very well. But we did not change boilers. We did not change chillers. There were no major equipments were changed. That's why our costs were down too. And in the end, we created system-level baselines for each equipment, not just at the whole building. We did look at it, but if you go up to the equipment level, major equipment level, you will probably have a better control over that. So we have a three-prong approach, and once that baby is set and ready to go, we dump it into the laps of Ron and say, you take care of it, and they do a good job. Next slide, please. Well, too much of a talking, but everything is kind of written in this paper. Please feel free to access this. More details are on this one, and feel free to contact the County of Los Angeles, who will be very happy to help everyone. Whoever needs to, we can share our scope of work, and we can help any way we can. We are open to a lot of things. After all, we are all brothers and sisters in the county. Done?
We're done.
Great, thanks you guys. Well, your brothers and sisters across California have a few questions for you. We have just a couple minutes before the next speaker, but let me try and get a couple of these in. The first question is, who conducts the training? Consultants, controls, measures, implementer, is that facilities staff? And who is trained, facility staff only or other building occupants as well? And can you share training materials?
The training is usually conducted by our RCX contractors, who are all engineering firms of one type or the other. And the training is specifically focused on the maintenance staff of the building. Generally speaking, there may be some building occupants or building management types there. Sometimes there's one or two people from the energy management group who are outside of the project group, but that's really operator training, trying to explain to them what their systems have and the nuances of those systems. Generally speaking, our maintenance staffs have a very defined opinion and education on how facilities work, what temperature set points are supposed to be on their equipment for their boilers and their chillers and things like that. And based on the tuning and how we're going to run it, we've got to explain to them how it works. So it's very, very focused on that operational staff. especially when it comes to resets. When you're resetting temperatures on your chillers and your boilers and all, you have to explain to them what the resets are and how they work and what triggers them, because they don't like seeing their chilled water at 55 degrees when they're used to seeing it at 45. They think there's something wrong with their equipment. They start making adjustments and going into manual control. We also take on all the documentation, besides the fact that we give them a full set of docs, blueprints, schematics, and everything. We keep hard copies up here. We put hard copies in the facilities. We put everything onto a disk, and we put everything on the network drives in the county so people can get them. Amar's passing me a note here, but I don't know what he. Oh, apparently we've got some quick reference guide also that we hand out. I've actually never seen it. This is new to me after 8 years today. I learned something. So that's the way it goes, man. Anyway, I don't know what we have to share on hand. I'm sure we have something. If people want to contact us and they'd like to speak, hey, how do you do this or how do you guys do that? We'll find out what we do if we've got any experience in it. We're very, very open and cooperative with other people. We share stuff all the time because we have no problems calling people and asking them what they do. So.
Great. So we will flash your emails at the end of the webinar, so make sure to get those down if you have any follow-up questions that you want to reach out to either Ron and Amar on. So I'm going to now move on to Peter, and we'll get to the additional questions at the end of the webinar. So Peter Livingston is with the County of Sacramento, or excuse me, County of San Diego. He's the Energy and Sustainability Manager for the Department of General Services. So Peter?
Next slide. Okay, well, why are we doing retrocommissioning? Really, I put down that we're obviously want to reduce our operating costs, improve the health and comfort of the building occupants, increase the facility staff knowledge, and possibly extend the equipment life if the equipment is excessively cycling, let's say something like that. I'm going to focus on 2 retrocommissioning efforts that we have. The first one is Central Plant Monitoring Reporting Program. We did this because we could get money from our local government partnership with San Diego Gas and Electric. And what we did is we went out and took our site, our vendor that had the control systems at the majority of our sites, and we went into the central plants and got a lot of information on how it operated. All these plants had been installed with Hartman loop technology, which is basically an overlay over the system to optimize the way that the chiller plant works. And it started to get out of tune and didn't know exactly why the power input per chilled water output, or kW per ton, was going up. And so that was one of our efforts. It was pretty successful in then identifying that, and then our controls contractor could make corrective actions. The other one that I'll focus more on is our Portland Energy Conservation Incorporated, or PECI, San Diego Retrocommissioning Program. We did that primarily because we could pay for almost all of the portions of the project with outside funding, and it was through the partnership that I mentioned and SDG&E on-bill financing. Next slide. So really quickly, the basics of this PECI retrocommissioning program: they only looked at sites over 100,000 square feet. You got a free free assessment. They looked at your benchmark against your peers and also expected at least a 5% reduction. So the screen assessment went up to the engineers up in Portland. If they didn't think you'd get it, they wouldn't give you an agreement. If they did, they prepared an agreement. Part of the agreement is free engineering assessment. You got to choose from a long list of engineering firms. Once you did that, in exchange for that, you were obligated to do any measure that had a 1 year or less simple payback. And between that 1 year and 8 years, they threw some incentives at that so that you would go ahead and do that project. And one really good feature of that, of this particular program, was that any measure that was approved by the engineering firm and that we selected would be financed with on-bill financing. On the back end, there's a measurement and verification effort that's paid by PECI but it's required to participate in. Next slide. Okay, so we did 4 projects one that we've done that I'll discuss in more detail, the Mills building, and 3 that we're in construction on currently. I've summarized the type of things that we're doing there. Primarily central plant HVAC work, but you can see we're also getting into domestic water heating. One place it was process HVAC. We got into some CO2 monitoring. At East Mesa, we actually took advantage of the on-bill financing to put retrocommissioning measures in, and 3 what we call therm measures, or outside of the retrocommissioning program. Those were also identified by an engineering firm that we were able to contract with through the partnership. So you can see we use a lot of the STG&E resources. I already discussed the central plants project that we went into. Next slide. So here's a summary of what we achieved and what we expect to achieve as a result of entering this project. The Mills building is a 10-story, 190,000 square foot office building right next to Petco Park downtown. It's co-habitated by the county and the Metropolitan Transit Authority. The North County Regional Center is a multi-purpose building, including detention facilities and courts that are now part of the state, about 415,000 square feet. Health Services Complex actually includes labs and the adjacent psychiatric hospital. One of the benefits of this is that we weren't able to accurately feed the psychiatric hospital from the Health Services Complex, and the retrocommissioning is helping us to do that, so we're accepting quite a bit of savings from that effort. And the East Mesa Detention Facility is what it sounds like. It's a big jail down right next to the border. So with the Mills building, we began that effort later than the other 3 projects, and we finished it a year sooner. And that's because we went through, it's a joint powers authority, somewhat outside the county, but our director of general services sits on the board. So that what we were able to do with the measures in a little more detail was the chillers, two screw chillers, they were manually operated. We were able to put automatic sequencing that was actually part of the controls but disabled in place. We were able to go and do a chilled water reset, another feature of the control system that was in place but not enabled. Condenser water reset, the condenser water was pretty much staying at 80 degrees year-round, plus or minus 1 degree. Screw chillers like it cooler, can go down to 65 degrees, so we put in a condenser water reset to have savings on that end. On our heating hot water system, again, manual operation by the property manager down there. We were able to go in auto sequencing strategy, do reset temperature based on outside air temperature, and also lock out the hot water system when the temperature went high enough. Our 5th measure was electric water heating. We don't need electric water heating necessarily on holidays and over the weekends, so we shut those down when we can, and included that with our centralized control system. Our air handling units, we went through and started training those. We noticed that the VAVs were not backing off properly. It resulted in finding out that the actual VAV box controllers were outdated and not really working properly, so we replaced those box controllers as well as implemented a static pressure reset programming to have those variable speed drives modulate like they should. The exhaust fans were for the bathrooms, or toilet and restrooms, were operating 724. We also put controls in there so that they were scheduled off-on when there's no occupancy. And our electric rooms were also operating continuously. We put the thermostats in there so that they would only turn on when the electric rooms rose above a certain temperature. We also, a little bit out of the network PC, but we went ahead and put a network PC power management controls into the PCs at the facility so that we could shut down the monitors and PCs when they were not in use a period of time. The last one that was pretty interesting was we had a server room that had been, because of the newer computer technology, had gotten smaller and smaller, but was still being operated and fed by a 100-ton air-cooled chiller. We were able to downsize that to 6 tons of cooling and disable the large system. Next slide. So how do we make this possible? Well, we couldn't just do it. We included the retrocommissioning as one of our execution strategies inside our strategic energy plan, which was approved by the Board of Supervisors. We also went before the board to receive approval to contract with PECI to enter the program for 5 sites. We ended up doing 4. And also, on-bill financing was a separate board letter that specifically mentioned retrocommissioning as one of the type of projects that we would use it for. And also, we'd never really had energy-savvy job order contracting contractors before. I won't go into the details of this, but they just bid against a price book, so you don't always know what you're going to get. But we would put a requirement in that they knew how the utility works and knew how the paperwork, expected paperwork. So that's helped quite a bit too. So those are some hurdles we had to overcome from that end. Next slide. Okay, so several challenges. People don't know about retrocommissioning. They don't know the ins and outs of the utility. A lot of education there. The time frame for purchasing contracting to review the agreement was longer than expected. The on-bill financing, because it was more sophisticated and new, a newer type of program, also took more time than probably it normally would. Some new legal issues between PECI, back and forth, all these things strung it out. Our project management was probably not aggressive enough, and maybe that was just because they didn't know about the program and getting the schedule moving in and getting everything done as quickly as probably could have been done. The energy program, I'm on the energy program. I'm not in facilities operations. I'm not in project management, but I depend on both of them to get this done. So there's a little bit of authority action going on there. Bridging a Public Utilities Commission cycle, yeah, that's an issue that can have contractual ramifications. One of the big issues that happened is our engineering budgets, in some cases, were not even close to what the contractor proposal was. That makes you go back and re-prepare and resubmit and all that stuff. So that's one thing to pay attention. Are you getting good numbers from the engineering firms? We had one site where the equipment failure in late stages required us to go to stage B after we had gone and assigned several documents. Fortunately, we were all able to work that out, but you never know when a control system is going to go south on you. Unlike LA County, we don't have dedicated staff for commissioning or retrocommissioning, so we really have other people do a lot of this thing. And then, of course, M&B gets tricky whenever you have operational changes in a really large facility like the ones we're doing in it. Next slide. I just want to briefly mention one of the features of what we're trying to do with our retrocommissioning project that sounds like LA County isn't doing, but it's new stuff for us, is to integrate the systems and bring our various buildings to a common web-based platform so that we can have specialized staff keep on top of our buildings over time and transition from just having to spend the money in a building at one point in time and then not paying attention to it for maybe a couple of years, is to be able to see it remotely and have people that know what they're doing keep on top of the performance over time so that we don't have that drift in reduction in performance like you might get if you don't see what's going on over time. Next slide. We'll just show this for, these are our targets for our pilot project that we just brought into place in September and starting the year-long pilot. Next slide. That's my presentation.
Great, thanks, Peter.
Yeah.
So we are at the end of our allocated time, so unfortunately we won't be able to get to the remaining questions, but I've captured all of them and we will be asking our panelists to respond to those questions by email. We'll make sure the answers are available on our website and let you know when that's up. So thanks to all of our speakers for sharing with us today, and thanks to everyone who tuned in. We hope that you found it useful. Our next webinar will be an overview of the 2013-2014 CPUC decision and will include information on the Bay Area and Southern California Regional Energy Networks and the statewide financing program. Please take a few minutes to fill out the survey. As I mentioned, your input will help us to offer events that cover the topics that you're interested in hearing about. That concludes our webinar today. Thanks very much for staying with us.